Book 9 of 10 books on architecture. Introduction. This LibriVox recording is in the public domain. Recording by Fredrik Karlsson. 10 books on architecture by Vitruvius, translated by Morris Hickey Morgan. Book 9. Introduction. 1. The ancestors of the Greek have appointed such great honors for the famous athletes who are victorious at the Olympian, Pythian, Isthmian, and Nemean games, that they are not only greeted with applause as they stand with palm and crown at the meeting itself, but even on returning to their several states in the triumph of victory, they ride into their cities and to their fathers' houses in 4-horse chariots, and enjoy fixed revenues for life at the public expense. When I think of this, I am amazed that the same honors and even greater are not bestowed upon those authors whose boundless services are performed for all time and for all nations. This would have been a practice all the more worth establishing, because in the case of athletes it is merely their own bodily frame that is strengthened by their training, whereas in the case of authors it is the mind, and not only their own but also man's in general, by the doctrines laid down in their books for the acquiring of knowledge and the sharpening of the intellect. 2. What does it signify to mankind that Milo of Croton and other victors of his class were invincible? Nothing, save that in their lifetime they were famous among their countrymen. But the doctrines of Pythagoras, Democritus, Plato, and Aristotle, and the daily life of other learned men, spent in constant industry, yield fresh and rich fruit not only to their own countrymen but also to all nations, and they who from their tender years are filled with plenteous learning which this fruit affords attain to the highest capacity of knowledge, and can introduce into the states civilized ways, impartial justice, and laws, things without which no state can be sound. 3. Since, therefore, these great benefits to individuals and to communities are due to the wisdom of authors, I think that not only should palms and crowns be bestowed upon them, but that they should even be granted triumphs and judged worthy of being consecrated in the dwellings of the gods. Of their many discoveries which have been useful for the development of human life, I will cite a few examples. On reviewing these, people will admit that honors ought of necessity to be bestowed upon them. 4. First of all, among the many very useful theorems of Plato, I will cite one as demonstrated by him. Suppose there is a place or a field in the form of a square, and we are required to double it. This has to be effected by means of lines correctly drawn, for it will take a kind of calculations not to be made by means of a mere multiplication. The following is the demonstration. A square place 10 feet long and 10 feet wide gives an area of 100 feet. Now, if it is required to double the square and to make one of 200 feet, we must ask how long will be the side of that square so as to get from this the 200 feet corresponding to the doubling of the area. Nobody can find this by means of arithmetic, for if we take 14, multiplication will give 196 feet, if 15, 225 feet. 5. Therefore, since this is inexplicable by arithmetic, let a diagonal line be drawn from angle to angle of that square of 10 feet in length and width, dividing it into 2 triangles of equal size, each 50 feet in area. Taking this diagonal line as the length, describe another square. Thus we shall have in the larger square 4 triangles of the same size and the same number of feet as the 2 of 50 feet each, which were formed by the diagonal line in the smaller square. In this way Plato demonstrated the doubling by means of lines, as the figure appended at the bottom of the page will show. 6. Then again, Pythagoras showed that a right angle can be formed without the contrivances of the artisan. Thus, the result which carpenters reach very laboriously, but scarcely to exactness, with their squares, can be demonstrated to perfection from the reasoning and methods of his teaching. If we take 3 rules, one 3 feet, the second 4 feet, and the third 5 feet in length, and join these rules together with their tips touching each other so as to make a triangular figure, they will form a right angle. Now, if a square be described on the length of each one of these rules, the square on the side of 3 feet in length will have an area of 9 feet, of 4 feet 16, of 5 25. 7. Thus the area in number of feet made up of 2 squares on the sides 3 and 4 feet in length is equalled by that of the 1 square described on the side of 5. When Pythagoras discovered this fact, he had no doubt that the Muses had guided him in the discovery, and it is said that he very gratefully offered sacrifice to them. This theorem affords a useful means of measuring many things, and it is particularly serviceable in the building of staircases in buildings, so that the steps may be at the proper levels. 8. Suppose the height of the story, from the flooring above to the ground below, to be divided into 3 parts. 5 of these will give the right length for the stringers of the stairway. Let 4 parts, each equal to one of the 3, composing the height between the upper story and the ground, be set off from the perpendicular, and there fix the lower ends of the stringers. In this manner the steps and the stairway itself will be properly placed. A figure of this also will be found appended below. 9. In the case of Archimedes, although he made many wonderful discoveries of diverse kinds, yet of them all the following, which I shall relate, seems to have been the result of a boundless ingenuity. Hero, after gaining the royal power in Syracuse, resolved, as a consequence of his successful exploits, to place in a certain temple a golden crown which he had vowed to the immortal gods. He contracted for its making at a fixed price, and weighed out a precise amount of gold to the contractor. At the appointed time the latter delivered to the king's satisfaction an exquisitely finished piece of handiwork, and it appeared that in weight the crown corresponded precisely to what the gold had weighed. 10. But afterwards a charge was made that gold had been abstracted, and an equivalent weight of silver had been added in the manufacture of the crown. Hero, thinking it an outrage that he had been tricked, and yet not knowing how to detect the theft, requested Archimedes to consider the matter. The latter, while the case was still on his mind, happened to go to the bath, and on getting into a tub observed that the more his body sank into it, the more water ran out over the tub. As this pointed out the way to explain the case in question, without a moment's delay and transported with joy, he jumped out of the tub and rushed home naked, crying with a loud voice that he had found what he was seeking. For as he ran he shouted repeatedly in Greek, Eureka, Eureka. 11. Taking this as the beginning of his discovery, it is said that he made 2 masses of the same weight as the crown, one of gold and the other of silver. After making them, he filled a large vessel with water to the very brim, and dropped the mass of silver into it. As much water ran out as was equal in bulk to that of the silver sunk in the vessel. Then, taking out the mass, he poured back the lost quantity of water, using a pint measure, until it was level with the brim as it had been before. Thus he found the weight of silver corresponding to a definite quantity of water. 12. After this experiment, he likewise dropped the mass of gold into the full vessel, and, on taking it out and measuring as before, found that not so much water was lost, but a smaller quantity, namely, as much less as a mass of gold lacks in bulk compared to a mass of silver of the same weight. Finally, filling the vessel again and dropping the crown itself into the same quantity of water, he found that more water ran over for the crown than for the mass of gold of the same weight. Hence, reasoning from the fact that more water was lost in the case of the crown than in that of the mass, he detected the mixing of silver with the gold, and made the theft of the contractor perfectly clear. 13. Now let us turn our thoughts to the researches of Archytas of Tarentum and Eratosthenes of Cyrene. They made many discoveries from mathematics which are welcome to men, and so, though they deserve our thanks for other discoveries, they are particularly worthy of admiration for their ideas in that field. For example, each in a different way solved the problem enjoined upon Delos by Apollo in an oracle, the doubling of the number of cubic feet in his altars. This done, he said, the inhabitants of the island would be delivered from an offence against religion. 14. Archytas solved it by his figure of the semi-cylinders, Eratosthenes by means of the instrument called mesolabe. Noting all these things with the great delight which learning gives, we cannot but be stirred by these discoveries when we reflect upon the influence of them one by one. I find also much for admiration in the books of Democritus on nature, and in his commentary entitled Keirakmeta, in which he made use of